x squared times e to the x to the negative x. Oh, I'm sorry, e to the negative x dx. I think u is x squared, dv is e to the
Okay,
negative.
so you said to yourself, I better do integration by parts, because I have a little product here. It's not an e to the u du. Why isn't it an e to the u du?
X squared.
Yeah, too much x squared extra. If this wasn't here, you'd be in good shape. So, okay, we're stuck, and we'll go with what you tried. You used u equals x squared?
Yeah.
And dv equals e to the negative x dx.
Mm-hmm.
So du was 2x dx, negative e to the negative x.
Sure.
So let's see. We have negative x squared e to the negative x minus the integral of
2 times
Take out negative 2.
2x.
Okay, so this piece times this piece. And you can clean as you go. Let's see what he did so we'll make it match his. Did you pull stuff out?
I brought the negative 2.
You brought the negative 2 out and left in the x,
E to the negative x.
e to the negative x dx.
Yeah.
So we're going to have to do it again,
Do it again, yeah.
Okay, so u was
X.
x, dv was e to the negative x, v was negative e to the negative x, du was dx. So I have now negative x squared e to the negative x plus 2 times uv minus the integral of v du.
And that's it.
Well, you know what? That's what you taught me the last time. You taught me that I may as well leave that negative in there
Yeah, you need
because
it.
I need it for du, right? But I do have it all behind this 2. So I'm going to have to distribute that 2 through. So let's see what we can do here. So, and we haven't done any of our definite integral part of this yet. So negative x squared e to the negative x minus 2x e to the negative x minus 2 e to the negative x.
Plus
No, evaluated from 0 to infinity. Because this was a definite interval. And
the first part's in the
nothing
second.
cleaned up. So let's see. I'm going to take
Pull
this
out
over.
the e to the negative x. Negative e to the negative x. We just plug e to
Well-
the negative x, the negative e to the negative x, like distribute it out. Pull it out. Make it easy.
As x approaches infinity,
That could work.
everything becomes 0. But as x approaches 0, the e becomes 1. That's 2.
I think you're all right. Either way, you did yours a piece at a time, and you did yours by first factoring.
That's what I would.
You would have factored first. I don't know which one's going to turn out better, but being the factoring sort of person, but then I might make 0 times infinities. I think I'm going to go a piece at a time. I'm going to go a piece at a time. So I have.
Do you make everything plus?
This is going to. I should make everything plus.
Because
Oh.
I ended
So
up
you
with
could
a
negative
negative 2 and the
So
answer
you
is
just have
2.
negative x squared
Oh,
over e to the
I'm
x.
going to leave the x's.
Just make
I'm
them
going
all
to leave the
fractions.
negative the way it is. But so just basically plugging in. This is going to be a negative infinity times e to the negative infinity,
0.
which is 1 over e to the infinity,
Should we make them all
which
fractions?
is a 0. So that's a L'Hopital's rule set up coming right there, which means this is going to be the same thing. This is going to be another negative infinity times a 0. And this is going to be a negative 2 times 0. So this piece zeroed out when I plugged in the infinity. So let's do the infinity piece, and then I'll do the minus, and then plugging in the 0. So here you probably would,
Fraction.
yeah, turn it into
E to the x.
e to the x.
Which is
And
infinity over
let's see,
infinity.
the top goes to infinity, the bottom goes to infinity. So I'm okay for a little L'Hopital's rule on this piece.
Are you
So,
doing it as it approaches infinity?
beg your pardon?
You're doing it as it approaches infinity?
Yeah, fundamental theorem, you have to plug the top number in first. So I'm approaching infinity. Yeah, and then I'm going to come back and do the 0 after I do all the infinities. Okay, so derivative of the top is negative 2x. Derivative of the bottom, e to the x. Another L'Hopital situation. This is negative infinity over positive infinity. So this piece now goes to negative 2 e to the x.
This is 0. Yeah, 0.
So negative 2 over
Infinity.
infinity. So this piece turned into 0.
Yeah.
I suspect so is that piece because it's a lot like it. So let's see, this we would do negative 2x over e to the x. So
Also, it's a
that's,
step ahead.
oh, you're right. So that is from there down telling me that this 2 is going to be a 0. And that piece already was a 0. Oh, great. So we did with the infinity. Now let's do, so right now we have 0 minus, now we have to plug in 0. So 0 times 1 is 0. 0 times 1 is 0.
It's negative 2.
E to the negative 0 is still e to the 0, which is 1 times negative 2 is negative 2. And when you distribute the minus sign through, I agree with what the guy had in the book. So now, did you find your missing subtraction sign? Your missing negative sign? Because you said you got negative 2.
Probably,
The-
he might have done like 0 minus infinity instead of 3 minus 0. Like, if you get it backwards, then you get 2 minus 0, and you get.
Well, he
Oh,
said he
you
turned
had
them all
two
into
biases.
pluses, right?
No, I didn't, but I realized you could.
It was a suggestion to factor out the negative. But
I think
this piece is the fundamental theorem that's happening right here, and that is you have to plug in the top number.
When I did the integral of infinity minus the integral of 0, I think I just put negative 2 instead of putting minus 2.
Okay, okay. And that was only number 25. So you have to realize that's a tough homework set. You need to give it some time and attention. Another one.